All right, let's talk about a great problem to have. So, you've built this amazing application, right? It's taking off. You're watching your user numbers just climb and climb every single day. First off, congratulations. That really is the dream. But as we're about to see, this kind of success brings a fascinating challenge, a real architect's dilemma. How do you build a system that doesn't just grow, but actually thrives under all that pressure? Let's dive in. And this, right here, this is what that success looks like. As your app gets popular, you get this incredible explosion of both active users and just the sheer volume of data they're generating. We're talking e-commerce orders, social media posts, you name it. Your database is suddenly a very, very busy place. Now, this is the best problem you could possibly have, but make no mistake, it is a problem that needs a solution, and fast. Because if you're not prepared, that dream can turn into a nightmare really quick. We're talking slow response times, frustrated users leaving, and worst of all, outages. The very systems that made you successful can become these crippling bottlenecks, threatening to bring the whole thing crashing down. So, how do we solve for this? Okay, the first enemy we have to conquer is downtime. Every single minute your application is offline, it's costing you users, it's costing you trust, and it's costing you money. The solution is this really powerful concept called high availability, or just HA for short. The goal here is simple. Make sure your application is always running, no matter what might be failing behind the scenes. To make this super simple, think of it like a concert. You could have your lead singer on stage with an identical backup singer just waiting in the wings, ready to jump in the second the lead singer loses their voice. That's what we call an active-passive setup. Or you could have a duet with both singers on stage performing at the same time, sharing the load. That's active-active. See? Both strategies prevent the show from stopping, but they work in fundamentally different ways.
So let's break down those trade-offs. Active-passive, that's your simple, effective backup plan. It's awesome for disaster recovery, but you might have a tiny delay while that backup server spins up and takes over. Active-active, on the other hand, that's all hands on deck. It's built for maximum uptime and performance, because everyone's working all the time. But that comes with some extra complexity in the setup and making sure the data is consistent everywhere.
And for that active-active duet to work together without a hitch, you absolutely need a conductor. In our world, that's called a load balancer. Just think of this thing as a dedicated traffic cop. It sits right at the front and intelligently directs all the incoming user requests to the different active servers. It makes sure no single server gets overwhelmed, which is just essential for keeping everything running smoothly and, more importantly, quickly. Okay, so we've solved for a server failing, but what about the data itself? What happens when your database grows from thousands of rows to billions? A single massive database will eventually slow to a crawl, and it doesn't matter how powerful the server is. This brings us to our next big solution, a technique called sharding. Let's try another analogy here. Imagine a single gigantic library, millions and millions of books all on one floor. Can you imagine trying to find a specific book? It would be a nightmare. Sharding is like splitting that library into dozens of smaller, specialized rooms. One for fiction, one for history, one for science. Now, when you need a book, you go straight to the right room. You're only searching a fraction of the collection, which makes it incredibly fast. And this shows the process perfectly. You start with one big monolithic database that's getting overloaded. Then you apply a logical rule to split it apart. And what's the result? Well, your data is now spread across multiple smaller and much faster databases that we call shards. Each shard is only handling a small piece of the puzzle, so queries are faster and the whole system can handle way more traffic. It's a game changer. Now, the most crucial part of this whole thing is that rule we just mentioned. It's called the shard key. This thing is the master organizer. It's a specific piece of your data, like a user ID or maybe a country code, that the system uses to decide exactly which shard a new piece of info belongs to. And let me tell you, choosing this key is one of the most important architectural decisions you'll ever make. So, what makes a good one? Well, there are pretty much 3 golden rules. First, it needs to have high cardinality. That's just a fancy way of saying it has lots of unique values, like a user ID. Second, low frequency. You want values that don't repeat too often, so the data gets spread out nice and evenly. And third, and this is a big one, it should be non-monotonically changing. This means you want to avoid a key that follows a predictable sequence, like an order timestamp, because that can cause all your new data to pile up on a single shard. And here's a perfect example of what I mean. A hashed user ID is a great shard key. It's unique, it's random, so new users get spread perfectly evenly across all your shards.
A terrible key? Order date. And why is that? Because it's always increasing. All your new orders for today would go to the exact same shard, creating what we call a hotspot, an overloaded shard that becomes a bottleneck for the entire system. You've got to avoid those.
Okay, so we've protected against a server failing, and we've scaled our database. But what about surviving a real catastrophe? I mean, what happens if an entire data center or even an entire geographic region goes completely offline? This brings us to the final frontier of architecture, the multi-region challenge. Why on earth would you take on this kind of complexity? Well, there are three huge reasons. The first is ultimate disaster recovery. If a whole AWS region like US East 1 goes down, your application can fail over and just keep running from Europe or Asia. Second, it reduces latency. By keeping data geographically closer to your users, you give them a much faster, snappier experience. And third, well, it's often a legal requirement. Lots of countries have data residency laws now that say user data must be stored within their borders.
But as pretty much any developer on a forum will tell you, going multi-region introduces one massive headache: data consistency. I mean, think about it. If a user in London updates their profile at the exact same time a user in Tokyo updates that same record, which update wins? How do you make sure both regions eventually see the same truth? This is the core problem right here.
And the answer? For most of these huge, large-scale systems is a concept called eventual consistency. And really, it's a trade-off. It's accepting that data across different regions won't be perfectly in sync for a few milliseconds, or maybe even a few seconds. The system guarantees that eventually all regions will get on the same page and converge on the same data. Services like Amazon's DynamoDB Global Tables are built entirely on this model to give you that incredible global performance.
So we have covered a lot of ground: high availability, sharding, and multi-region deployment. And it is so important to understand that these aren't just steps on a list. They are powerful tools in an architect's toolkit. Each one has its own benefits, its own complexities, and its own costs. The real skill is knowing which one to use and when to use it. This table really sums up our toolkit nicely. You can see how each strategy offers a different level of resilience, but it comes with more and more complexity. The architect's real job isn't just knowing what these tools are, but choosing the right one for their specific needs. Balancing uptime, scale, and of course, cost. And that brings us to the final question for you. As you think about your next project, or maybe how to scale your current one, these are the exact decisions you're gonna face. Surviving success isn't about luck. It's about architecture. It's about making deliberate choices to build a system that's not just successful today, but is resilient enough for whatever the future throws at it. So, what will you build?